All right, so today we are going to be talking about creating single line diagrams in Revit. Before I do that, I do want to introduce myself so you know who I am. My name is David Robison, and I have been working with electrical engineers, helping them with their design processes in AutoCAD and Revit for over 20 years now. And during that time, I've had the opportunity to work with over 600 different engineers at different companies. So I've been able to see a lot of different ways that people do their electrical design. I've seen lots of different ways of doing single line diagrams, both in AutoCAD and in Revit. So today I want to share with you the best practices that I've seen from engineers for doing their single line diagrams. I want to share with you how they think about their single line diagrams, how they think about Revit, to be the most effective and the most productive with the tools they have available to them. And actually, before we do that, I do want to ask the question, what's the hardest part of creating single line diagrams in Revit? Just go ahead and let me know in the chat, where do you struggle the most with single line diagrams? And the kind of answers I normally see for this are having trouble keeping the single line coordinated with the model. Other times people have trouble with the actual drafting in Revit, getting their families created. Just using Revit for the single line diagram at all. So those are the common answers I see for this question. So I want to share with you today a framework that my best customers, the people I'm working with, use to evaluate their electrical designs and to do their single line diagrams in Revit. And we call this framework the electrical design triangle. And as you can see, it's a triangle. It has three sides to it. The first side is the single line diagram. That's what we're talking about today. This is where you are laying out your panels, doing your feeder sizing, making all your connections for your single line. But that's not all that you have happening for your electrical design. We also have the Revit model. We're talking about single line diagrams in Revit. So the Revit model is a key part of that. And then we have the calculations as well. And this is where you are sizing your wires, setting the actual wire size, using that wire size to calculate voltage drops, to do short circuit analysis, and things of that nature. So the single line diagram doesn't exist by itself. You actually have these other pieces as well. So I'm going to walk through each side of the electrical design triangle and then talk about how you can use this framework to think about the single line diagram that you're doing in Revit. Let's talk first about the Revit model. So we are talking about single line diagrams in Revit. So there's going to be a Revit model behind what we're doing for our electrical design. And you want to be using Revit to its full capabilities in order to be doing an effective single line diagram. To do an effective single line diagram in Revit, step one is to be able to use Revit as much as possible. There's a couple of features in Revit I do want to highlight. The first are families. So this feature is not an electrical feature. This is a Revit feature. But you want to be comfortable creating families, using families, opening them up, taking a look at them, seeing how they're constructed, modifying them, just understanding families as much as possible. Families are the building blocks of what you're doing in Revit. The more you understand how families work, the more effective you're going to be in Revit. So you want to make sure that you have a good understanding of how families work, or at least you or someone in your company. You need to be able to be working in your families to create the pieces for your models so that they are being defined well and properly. The other Revit feature I want to highlight are shared parameters. This is information you can put in your family, either to drive the geometry or to store information about that family. And then you can use these shared parameters to do all of the scheduling that Revit allows you to do. So your families are going to be holding all of these shared parameters, and you want to be comfortable creating these, again, modifying them, inspecting them, and then using them for your schedules and for your annotations. So the more comfortable you are with shared parameters, the more effective you're going to be with your single line diagram and just with your design and overall in Revit. So those are the two big Revit features that you want to have a good handle on, families and shared parameters. Then in Revit itself, it has a number of electrical features, and you want to make sure that you're using all of these features as much as possible. So Revit has electrical equipment, which they use to define panels and transformers. You want to be comfortable creating those, connecting them to each other, using those for your panel schedules. Then for your actual device layout, you want to be using Revit and understanding how to put in your receptacles, your light fixtures, your equipment connections, how to circuit those to your panels to make your connections, how to get the loads on those properly, and have as much of the load calculation happening in Revit as possible. Now, we could probably do multiple hours on just this slide about how to do electrical design in Revit. And we're not going to go over that today. There's lots of other resources out there. So if you have questions on this, you want to make sure that you go and are using those other resources so that you're using Revit for electrical design as much as possible. But I just do want to highlight that these are the types of things you need to be doing in Revit before you start thinking about single line diagrams. You want to make sure that just your Revit usage is really dialed in. From there, then we can start thinking about the single line diagram side of the electrical design triangle. Here, I'm going to pull up Revit. And the first question we have to answer with the single line diagram is, where is that even going to live? When you first start working in Revit, you're usually coming from AutoCAD, and your single line diagram lives in AutoCAD. Then you have to deal with all of the complexity of linking an AutoCAD drawing with your Revit model, dealing with all the problems that brings with the links. So you want to get your single line diagram out of AutoCAD and into Revit so that you're working in a single platform. You have your single line diagram as part of your model in Revit. Then once you're in Revit, you have to figure out, where is that single line diagram going to live? I have here the sample project from Revit 2022. This is the older sample project that Autodesk used to ship with Revit. And when you opened up the systems sample, it actually opened up to this view here, which is their main electrical distribution system. And looking at this, there's the idea that maybe they were thinking this could act as a single line diagram or the beginning of one. You've got your panels laid out, you've got some connections happening. But if you try and use this for a single line diagram, you very, very quickly realize that this doesn't work. Even Autodesk in their sample project got tired of drawing feeders, so they don't actually have all the feeders in there. There's none of the labeling. And if you actually try and lay anything out, it's not going to work because this is the 3D representation and it's not a diagram, so you can't really move things around so that they're readable and understandable. So this is kind of a cute idea that Autodesk had, but you actually can't just cut a section and call it a single line diagram. You need something that's different. That's the whole point of the single line diagram. It's not a 3D representation. So you don't want to try and do a section like this. The next place that a lot of people attempt to do a single line diagram is on their floor plans themselves, where you've got your floor plan over here on the left, and then you kind of come over to where you've got some empty space, and you start doing your drafting here. This has one advantage in that you can actually have these labels linked to the pieces in the model. So this LP1 is actually a label to this panel over here. And then when you make changes in the model, it's going to update in the single line. That's kind of helpful. The problem, though, is that they're a little bit too linked. So if I come here and actually move this panel, I select that panel, and I'm going to move it to a new wall over here, you can see that the label on our single line diagram got moved with the panel. So anytime you make a change to the model, your single line diagram is going to have labels going all over the place, and then you're going to have to move them back to where they were. So you don't want them that tightly coupled. You also have this drafting stuff off in space on your floor plan, which is kind of weird. It doesn't really belong there. So you don't want to use a floor plan for your single line diagram. You are going to be best off if you put that single line diagram on a separate drafting view. And you want to have a drafting view in Revit for your single line diagram. If you have a big single line diagram, it's actually going to have to span multiple drafting views because you can only do one drafting view per sheet. So if you have multiple sheets, each sheet gets its own separate drafting view. But you want the single line diagram in these drafting views. Then once you're in the drafting view, you can start using the Revit model stuff that we were talking about, the families and the shared parameters, to assist with your drafting. So you can put together some families like I have here. I've got this transformer. It's currently solid. There's also an option to change it to dashed. So you can have different types linked to graphics. You can have these grips here, and you can move them around to adjust the sizing of things. So you can put together families that look nice, that behave nicely, that make your drafting simple and straightforward in Revit. You want to make sure that these graphics are consistent throughout your firm. You don't want to have each individual engineer creating their own graphics. For one thing, it just means that everyone's spending a bunch of time on those families rather than doing productive engineering work. And then you also have inconsistencies in the projects that are going out. You want to have one look and feel for your single line diagrams. So you want to have someone in some process for creating graphics that are consistent and a place to store them so that when you're pulling a graphic, you can easily pull a panel, you can pull a transformer, and you don't have to hunt it down or think about what families you're going to be using. You also want to make sure that what is happening on this single line diagram is consistent with what's happening in your model. That when you make a change in one place, it's going to happen in the other. So here we've got this panel, that LP1 that we were looking at. It's also shown on the single line diagram here. And if we make a change to this panel, we want to make sure that that change updates in both places. So if we take this LP1, and we've also got an LP1B. If we call this LP1A, we just change that name. We want to make sure that it updates here in the model, and then it also updates in the single line diagram at the same time. So you want to put together processes for making sure that that is happening. So the next place I want to take a look at is the last side of the electrical design triangle, and that is the calculations. And so this is where, as electrical engineers, we're really adding our value to the project. This is where we're doing all of our engineering work. This is where you're choosing your wire sizes, and you're doing a voltage drop calculation. You're doing your selective coordination, all that stuff that you as an engineer have to do for the electrical design. And we'd like to think that we have a nice single model for our electrical design process, and that it's one place where all the information lives, and we can pull all our information out of it. In reality, it's not as straightforward and clean as that. You have some stuff in Revit. You're going to be putting your devices in Revit. They have loads. You're going to be doing your panel schedules in Revit, but not everything happens in Revit. So you probably have some stuff in an Excel spreadsheet that you've created over the years. You might be doing your voltage drop or your feeder sizing in an Excel spreadsheet. And it's probably not just one Excel spreadsheet. You probably have 3 or 4 of these Excel spreadsheets. So you've got multiple Excel spreadsheets where you're doing your calculations. You might be using another tool like Mike Holt's online calculators. So you might be using other resources for doing your calculations. In fact, you might be using a third-party package, something like Easy Power or ETAP or SKM. So you might be stepping out to those places and doing your modeling there for your calculations. And then there's other calculations like lighting, where you're either doing Elam tools inside of Revit or visual outside of Revit. So you've got all these different calculations in all of these different places. And so it starts to get a little bit messy in terms of what you're doing with your calculations there. Now, what you want to do with the electrical design triangle is that you want to make sure that changes in one place are happening in the other. So if we come here and we make a change to the single line diagram, we change a panel name, we want to have that panel name changed in the Revit model as well. We also want to have that changed in our calculation model so that we've got the same panel name being used in all the different places. If we're in the Revit model and we move a panel, we want to make sure that that is updating our wire lengths in our calculations. If we change how things are connected in the Revit model, that needs to update in our calculations. That's going to need to update in the single line diagram as well. And then if you're working in the calculation, you do your voltage drop and you realize you need to upsize a wire for voltage drop. You're going to need to have that update in your single line diagram, and you need to update that in the Revit model. So every time you make a change on one side of this triangle, you need to make a change in the other. Key here is that for the single line diagram, it doesn't live by itself. It's not in isolation. It is connected to these other two pieces. And the real trick with being effective with your single line diagram is making sure that changes there are happening in the other places. And when changes happen in the other places, they also happen in the single line diagram as well. So we can use this framework now to think through where and how changes should be made. So as an example, we've got our electrical design triangle, we've got the single line diagram, the Revit model, and the calculations. Let's say we're inserting a meter on the project. So that's going to go over here on the single line diagram. We put our meter on the single line diagram. And then we can think about, okay, is that going to go on the Revit model? You might not actually be inserting your meters on your Revit model. A lot of times you're not actually modeling everything in 3D in Revit. So the single line, so the electrical design triangle helps you think through where else you actually need to make this change. In this case, it actually doesn't impact the Revit model at all. The same with the calculations. The meter isn't really going to impact the voltage drop or your wire sizes. So it might not show up in the calculation. So something like a meter is straightforward. It's some drafting on the single line diagram. It doesn't impact the other two places. All right, same thing. We've got the electrical design triangle. Let's say we're over here in the calculations and we need to upsize a wire. We're going from a number 12. We're going to upsize that to a number 10. We made that change in the calculations. Now we actually need to make sure that if that's shown on the single line diagram, this information shows up here as well. So we need to have the number 10 being shown on the single line diagram if it's being used. This obviously is not feeder. It's going to be some sort of branch circuit, but that's feeding a piece of equipment. You want to make sure that that has the right size to that piece of equipment. And then in the Revit model, if that's showing up anywhere in your panel schedule or on a home run, you want to make sure that that shows up there as well. So anytime you make a change in that calculation, you need to think through, get it in the single line diagram in the Revit model. So something like a voltage drop, wire upsize, you need to get that in the other places. One more example, say we're doing a bus gutter. A bus gutter is a good example because Revit doesn't actually handle these very well. And so the electrical design triangle can help you think through what that is going to mean to actually put a bus gutter in your project. So you're probably going to start by drafting it on the single line diagram. So we put our panel in, it's got a bus gutter going up it, and then we've got some other panels that are fed from it. There's some connection point, and we've got our feeder going here. So you're going to have something like that for your single line diagram. So there's some drafting to get all this inserted. Then we can go over to our Revit model. And we can start thinking through what that's going to look like. So we, again, have probably our building. We've got a couple different floors here. We're going to put our panel in here. And then we've got these other panels. And the bus gutter is a little bit weird in Revit because it's not actually going to be part of the connection. So maybe there's some 3D drafting that you do to represent this bus gutter so that you're just blocking out the space. And in terms of the electrical model, maybe you're putting some connection points here, and then you do a feeder to connect these panels to those connection points, connect those to each other into that other panel. So you can make your connections and have everything connected in Revit so that the loads are going to calculate properly. And then finally, in the calculations themselves, in your Excel spreadsheet, in your third-party package, you're going to put that bus gutter in, so you need to model that. You're going to have those two panels. You need to make sure that you have connections between them so that you can size that bus gutter, size any feeders to them. So you're going to have these essentially 3 different models, but you can model it differently in each different place and make sure that it's being handled properly in them. So this framework of the electrical design triangle helps you think through the different ways that you need to model it in all of the different parts of the triangle. And the key, again, with the electrical design triangle is that when you make changes in one place, you want to have those changes happen in the other. So think for a moment, how would that feel if when you made a change on one side of the electrical design triangle, if you made a change in one of these places, how would it feel if it updated automatically in the others as well? What would that look like for your company? How would that impact your productivity? How would that impact your quality control processes? What would that look like for your company if you were automatically updating everything? So there's 3 ways you can make this data transfer happen. The first, and the most basic way, and the way that most people start out with, is you're just manually transferring data. So you have these 3 sides of the electrical design triangle. You make a change in one place, and then you manually make that change in the other place. And so if you're doing these manual data transfers, you need to make sure that you have good processes in place when you make a change in one place, that it happens in the other places as well. You want to have checklists and workflows for making sure that happens. You want to have good review tools to make sure that when you make a change, that you check that before a project goes out to make sure that everything's consistent throughout your project. So that's the manual data transfer option. The other thing you can do is you can start looking at ways to automatically transfer this data using in-house customization. So Revit has automation tools built into it. They've got Dynamo for their scripting. They've got their .NET APIs. So you have various tools available to you for automating some of this data transfer. And so you can start using that automation that Revit has available to do this data transfer using your own in-house abilities. Either you as the engineer can put together some scripts for yourself. Larger companies can have their automation team, their BIM team, work on this for them and put together tools that you can use for this data transfer. That does require, obviously, a fairly large investment of time, either taking valuable engineering time to be working on this internal tooling, or to be putting together a whole department to handle this for your company. So it's not insignificant, but you can do this automation yourself. You can also just look to see if any of these other tools, if you're using a third-party package, what kind of data transfer it has built in between itself and Revit. Which kind of brings us to the other option, where you can have the automatic data transfer where it's done for you, where you're using someone else's implementation, where someone else has put this together, and then you're actually purchasing software to do this data transfer, either a third-party package or something in Revit. And so what my company, Design Master Software, has done is we have put together a tool that we call ElectroBIM that automates this data transfer of the 3 sides of the electrical design triangle. So we move all of that stuff in those 3 different places, and we put it all inside of Revit for you. So ElectroBIM has won a number of awards over the years. We've been around for 10 years. We started in 2013. We got an award for consulting specifying engineering in 2014, EC&M in 2017, consulting specifying engineering in 2023, and then we actually just got the 2024 award as well. I haven't updated this slide. So we've been around for quite a while and been recognized for the quality of our software. We have a number of users across the country using this software. And just speaking with some of them, they're seeing savings on their whole project of 65% of their time, and they're reducing their errors by 30%, or they're cutting their design time in half. So if you can take this electrical design triangle and you can link those sides together, you can see huge savings in time and increases in quality by having this automated. So let's go back to the electrical design triangle again, and we can look at how ElectroBIM handles each of those sides of the triangle. So on the Revit model, we're still using Revit as the basis for the design. So you're working in Revit, and you're using all of Revit's electrical features, or at least most of them, the ones that we were able to salvage and use. So you're still doing your panels and transformers in Revit. You're inserting those in your model. You're creating all of your devices, light fixtures, receptacles in your model, laying out your floor plans, circuiting things together, connecting them in your panels, and doing your panel schedule. So all of that still happens in Revit the same way you've been doing it up to this point. Then ElectroBIM in Revit is going to take over your breaker and wire sizing. So on the breaker sizing, Revit doesn't do a whole lot there. So we actually add some automation. So we give you the proper breaker sizes, and then we actually size the wires for you and let you change those, where Revit doesn't really let you do that. So we took over the wire sizing and implemented it ourselves using our software. For the single line diagram, we have all of this information inserted in a drafting view that's linked to your Revit model. So what's happening on the single line diagram and what's happening in the Revit model are actually linked, so that those are being seen as the same pieces, and updates to one are happening in the other. Then finally, on the calculations, we've pulled as many of those calculations into Revit as possible. Like I said, we have the breaker sizing and the wire sizing. Once you have a wire size and you also know the location, so you can get wire lengths, then you can do things like voltage drop calculations in Revit, and you can do short circuit analysis. You can even go from there and do arc flash coordination. And we have a breaker database, so you can do your selective coordination as well. So all of those calculations you can take out of your third-party packages, out of your Excel spreadsheets, and you can move them into Revit itself. So let's take a look at how that actually works in Revit. So going back to Revit here, I've got this single line diagram. So this is a drafting view, and this was built using ElectroBIM. So everything that's in here is actually linked with the electrical model. So if I run our highlight device command, I select that LP1A, it knows that it's connected to this panel in the model. That panel shows up here. It shows up in the single line. It also shows up on this panel schedule as well, because it's connected to this MVP1. So now if we use our software to make a change to that panel, it's going to update in all three of those places. So we take that LP1A, maybe we want to go back to LP1. Maybe we're going to update this breaker, this panel size. It's currently a 100 amp panel. Let's change this to 125 amp. That updates here on the floor plan. So now it's LP1. Over on the single line diagram, it updates here as well. It's an LP1 panel. It's now 125 amp panel. It has 125 amp feeder, 125 amp breaker. So that's all updated on the single line diagram as well. And then over in the panel schedule, it's updated here as well. So our circuit description updated, our breaker size updated. So you make a change in one place, and then that's updating everywhere for you on that electrical design triangle. I was also talking about, with the single line diagram, having consistent graphics. ElectroBIM manages all of your graphics for you. So we're using standard Revit families for these graphics. So getting these graphics right, I don't know what your single line diagram looks like. I know it doesn't look like this, but it looks something like this. So you can customize these graphics using standard Revit functionality, modify these families, make them look how you want them to look, but then our software is going to be using that and link it to the rest of your model. Our software also manages all of these families. So you can have one person who's going to do all of that work. They're going to update the graphics, make them look right. Then our software handles all of that customization, stores it in a standard location so that when your engineers are thinking about putting in panels and putting in transformers, they're not thinking about, okay, where are Revit families located? What folder is that in? Which family do I choose? Did I get the right one? Instead, they're using our software and just running commands to insert a panel. And they're thinking about it from the electrical standpoint. So we've got this MDP3 here. There's a bunch of stuff that's not connected to it. ElectroBIM can actually insert all of that for us. So it can use all of the panels and all that graphics that we've defined, and it will make those, insert everything for us, insert the feeders, lay it all out, have it all connected. If we want to insert something new, we can also do that. So this was stuff that already existed in the Revit model. We've added it to the single line diagram. If you want to put something in new, we have commands to do that. So we can create a new panel. I'll call this P new. We do need to tell it what level it's going to live on because Revit really cares about that. So if you don't have your project yet, it's just going to kind of go off in space. So we'll put it on level 1. We choose our distribution system. Then we choose our graphic for the single line and the graphic for the model. And we can insert this in the single line here. We can make our connection. So the panel goes on the single line. It's now connected. I'll go ahead and put another panel in. Call this one P new 2. Connect that one to P new. So you can build out your single line, create your panels, make your connections. Then over in Revit, if we highlight that device, we can see that these panels are being created in Revit. They're off in space. So you'll need to later go back and locate these where they belong. This way, you can actually start building your electrical model. You can build your single line diagram before you even have the architectural model, before you have your electrical room. You can start working on that single line diagram in a way that's going to be useful and able to be carried forward in the rest of your project. So once you actually have your project, you have your rooms, you can select these panels and then you can put them in the right spot. Obviously, if you want to put them in the right spot to begin with, you insert them in Revit, and then you run that generate, or we also have the insert link command where you can insert something that's in the Revit model. So if you know where they go, just put them where they belong, and then put them on the single line diagram. So you can work either way. You can start in the electrical, the Revit model, put them there. You can start in the single line diagram, put them there, and it works both ways. We also do all of our calculations in Revit, so you don't need to step outside to Excel, to other third-party packages for those calculations. Now, I'm not going to say we do everything that something like SKM does, because it does a lot of calculations. But for what you're doing for a standard commercial building, you can actually do all of that within our software using Revit. So if I go to my schedule and I go to my voltage drop schedule, you can see the voltage drop to all of our panels. And this is being calculated for us. And so then we can see that we've got this voltage drop here that's over 3%. Now we actually can change a wire size and have that update automatically. So we can come in here, run the panel edit. It's actually the panel upstream of it that we need to change. So we'll take that PP2B. And I'm going to upsize that panel, that wire size. We can manually upsize the wires. We also can configure the software to automatically resize wires for voltage drop. And we will run our calculation. And that's going to update all of our calculations based upon any changes we've made. So it's going to look at the locations, the wire sizes, and redo all the calculations for us. So now it's updated all of those wire sizes for voltage drop. And then over on our single line diagram, it's actually updated the information here as well. So it's given us our new voltage drop numbers, and it's given us our new feeder sizes as well. So this PP2B, we upsized from a 250 to a 300 amp wire. That's being represented here with this 300A. And since we upsized it for voltage drop, we also upsized the ground. So it's got a different tag than this one over here that's got the standard ground. So we're keeping track of all of that information for you. It's being notated on our feeder schedule. So we have those two different feeder sizes with the two different grounds. So those calculations are happening inside of Revit without having to step out into another package. For all of the wire lengths, we're pulling those from the Revit model. This is where the benefit of BIM really comes into play, where you've got this Revit model, you have your devices laid out, and we actually know where everything is, and then we can use that to calculate a feeder length. We've got a couple different ways of calculating those feeder lengths. I'm not going to show all of those right now, but if we take a look at this panel, we can see that the software does know what that feeder length is. So it's currently 180 feet to the panel it's connected to. If I move this panel, put it back where it belongs in this electrical room. So it was 180 feet. And now we look at that panel again. We can see that the feeder length has changed to 196. So you make a change to the model and that feeder length is updated. And then that feeder length is going to drive the voltage drop calculation and your fault analysis. So you have the option of continuing to link the sides of the electrical design triangle manually, transferring data as you are now. You can look for ways to automate that yourself. And that's certainly what a lot of people do. A lot of companies are doing that. They're building their own tools. Or you can look to something like ElectroBIM that has this already built and use this to do the automation of these three different sides. There's really two steps from here in terms of what you're going to do next. You can either schedule a Revit workflow review with us where I can walk through what you're doing in Revit now, talk about what our software is doing, and see if there's going to be a fit between the two. You can also just download a free trial and start playing with it yourself. So you don't need to talk to us. You can just download it, install it, see how it works in Revit. And I'm going to put those two links in the chat where you can either schedule a workflow review or download a free trial. If you're watching the recording of this, those links will be either in the video comments, the video description, or on the page where you're watching this. So if you click the schedule workflow review, that's going to take you to this page here, where you can choose a time on my calendar and choose a time where you want to sit down and walk through Revit and what you're doing and talk with me about it. And we can take a look at what our software does, what you're doing, and see how that would be a good fit or not. The free trial will take you to this page where you can just download the software. We will send you resources on getting started, on how to use the software, and so you can give it a try on your own, just directly working with it in Revit. The trial that you get is not time limited. It is an unlimited trial. However, it is going to watermark the output. So you're going to have little EBIMs or -1s in various places that'll randomly show up when you calculate. That's so you can't actually publish a drawing with it, but you can test it out for as long as you need to. So you can play with it, see how it works, make sure it's going to work. And then when you want to start doing actual projects, actually publishing something, you can purchase a license and all of those watermarks will go away. So it's an unlimited time trial, but the output is watermarked. So when you're using it, just be aware that's what those watermarks are going to be. So if you have any questions, feel free to put those in the chat and I'd be happy to answer those right now. One question is, what versions of Revit does this work on? So we work, as you can see, in Revit 2025. So we're up to date with the latest version of Revit. If you're watching this at a later date, it's going to be up to date with whatever version of Revit is the latest version. And then we support a couple versions back. We try not to drop support too quickly. So the current version works back to Revit 2020. We have older versions that work all the way back to Revit 2014. Probably wouldn't recommend that you use our software on that, but it is available. And if you had a project that was still using it, we're going to support that with the version of our software that was available at the time. Another question on the single line diagram. Does this require special families to work, or actually in the model as well? So how do families work with our software and what you're doing today? So what you're using here in your model, the families are going to be exactly the same. You do not need to use our families. We assume that you already have your own families in Revit. And so you're going to be using those to be doing your modeling. And we're not going to change that. So you work with the families you already have. You can make some changes with our software. If I edit this family, we have our own command to add some additional information to make it work a little better. It's not strictly required. So your model families are going to be exactly the same. On your single line diagram, you're going to either need to use ours or modify them to work with your single line. So typically you take our families and modify them, or you can take yours and modify them to work. So there's a little bit more work on the single line diagram to get them to link nicely with the rest of your model. So the single line diagram, you'll need to make some modifications and spend some time. On the model itself, the families you have today are going to work exactly as they do already. Another question is, how reliable are these calculations? So we've been in business for over 20 years at this point. So we've had lots of engineers using our software and checking our calculations. And what I'm going to say is that when you first get the software and you try it out and you compare it to your calculations today, you're going to get a different answer. And the reason for that is that you're going to do your input differently in the two programs. Once you have your inputs the same, you will get the same output as what you're getting today. So our calculations are going to match anything that you're using, either your Excel spreadsheet or other third-party packages. We give you the same output. So if you're not seeing that same output, go back, check your inputs, make sure they're the same. If they're not and you have trouble, feel free to contact us. We can give you a hand figuring out where that difference is. And then once you get the inputs the same, you'll have the same outputs. That's also a good way to make sure you're understanding how our software works. Once you can get those outputs the same, you're understanding that you're modeling it the same into both programs, and then you can be confident in how you're using the software. Another question is, does it work in BIM 360 or Autodesk Construction Cloud or whatever they happen to be calling their cloud-based file server structure to this day? And the answer is yes, we do. So we are working inside of Revit, using Revit as much as we can. So all of Revit's functionality for transferring data to and from the cloud, our software takes advantage of. So we're using all of that native Revit functionality. However you're doing your file management today works just the same with ElectroBIM. So there's no changes needed in terms of that with our software. It works exactly the same way. Another question is, can I customize the feeder sizes with the software? You can. So all of these feeder sizes you have complete control over. And we've got a number of different places where you can do that. Just at the core, we have this wire ampacity where you specify, for a 20 amp feeder, it's going to be a number 12 wire. Pretty standard. Not many people are going to change that. But as you start to get up to the larger sizes wires, for a 400 amp wire, we're currently using a 600 kc mil. Maybe you want to do 2 runs of 3/0. You can customize that in our software. So you can customize what's going to be used for different configurations of wires. And then you can actually choose the specific wire sizes, like we saw with PP2B. We give you a wire size, we calculate that for you, but you always have the ability to go in here and override it. We can come in here and change this to a new wire size. If you want to change it from copper to aluminum, we could do that. So we could say, hey, this one feeder, I want this to be an aluminum feeder, everything else is copper, or something like that. So you have complete control over the sizing of your wire. We always give you good defaults, but we let you override that because you, as the engineer, need to have control over what your design looks like. If you ever get into a situation where we can't model your wire properly, we even have this custom option where you can just type in a call out, give us your impedances, and that's what we're going to do our calculations on. So there's literally any sort of wire configuration our software can handle, most of it through our built-in tools. And then if not, we always have custom to fall back on. Same with something like length. We're going to calculate this based upon your Revit model, straight lines or right angles, however you want it to be. We also have the fixed length. So if you just want to type in a length, you can do that. Tell us what the length of the wire is. We'll use that for the calculations. And that's pretty much how we do everything in our software. We give you good defaults. We calculate things for you, but we let you as the engineer override that so that you can give us the actual values in cases where the automatic calculations are not correct. Maybe not correct is not the right way, but where you have a situation where you're doing it a little bit differently than our automatic assumptions are doing it. So again, if you want to learn more, feel free to use that link to schedule a workflow review. We can sit down, talk through how to use our software, or go straight to downloading a free trial, get it installed in Revit and see how it works for you and your company and what you're doing. If you do have any questions while doing the free trial, feel free to reach out to us and talk to us. We're happy to answer any support questions that you have during that free trial. So you can reach out to our support team using all of our standard support resources, email, phone call, live chat, and we'll answer those questions and make sure that you're having success trying the software. So that's the electrical design triangle. It's the framework that we use for thinking through how to do your electrical design in Revit. You can either use that for thinking through your manual processes. You can use this as a framework for starting to add some automation to add these links, or you can look for a tool like ElectroBIM to handle all of this for you. So those are kind of the three different ways you can use this, but something that no matter how you're doing your design, which of those ways you choose, it is a good way to think through what you're doing and make sure that the changes that you're doing, where that change needs to happen, what that change is going to look like. And again, if you want to learn more, feel free to schedule that evaluation, do a free trial. Feel free to reach out to us. You can go to our website, designmastery.biz, and contact us there if you have other questions about our software.